right, so I'm here to talk about an exciting project coming out of Stanford, the BioNet 10K Gene Project. And if any of you don't know what BioNet is a new project that is aimed at open sourcing biology. Because, as we know, it's mostly closed source, and we'll get into that later. Who am I? I'm Keoni. I work at the ND Lab at Stanford, and I've been biohacking for about 5 years. And this is the picture of my favorite organism, Mesoplaza florum. I hope to eventually synthesize that myself. So, the BioNet project aims to open source biology. What does that mean? As Michael said yesterday, there's a lot of issues with patents and MTAs. And specifically, MTAs suck. They're the worst. The UBMTA defines lots of terms that you can't redistribute material and that you have to sign with each and every person that you share material with, which makes it really slow to transact between institutions. So there's an idea, the Open MTA. We'll get into the Open MTA in the next slide, but essentially it is an open source MTA for biology that stipulates that you can share material and that you can use it in commercial applications, which is a great advancement over the UBMTA. And probably what's most exciting about this project is that we have gotten a twist synthesis deal for 10,000 genes, 1.8 kilobase per fragments, and we want material to synthesize, and that comes from you. We'll get into that in the next few slides. So, what is the Open MTA, and how is it different than the UBMTA, and why are we using it, and why is it worth developing, and why is it worth talking about? So, out of these list of things, I've bolded what I think is most important. The Open MTA, unlike the other currently used MTAs, allows for commercial use of material and the distribution of derivatives and that material. So if an institution signs the Open MTA, which Stanford has a line, and the BioBricks Foundation has a line of different institutions such as Caltech that have already signed, or are going to sign, signatories of the Open MTA, if you get material from them, you can give it to whoever you want. You can give it to your biohacking friends, and we're even partnering with Adgene to get some of their most commonly used plasmids synthesized. So now, instead of having to sign the annoying MTAs with Adgene, you can just sign the Open MTA and they can send it to you directly. And then you can share that with whoever you want. And you can use it for commercial purposes, industrial purposes. You can use it however you want. So, if you would like to check out the Open MTA and what it's about and open sourcing biology, here's a link. It's still open for comments. It's still getting drafted. It should be out late September, early October, where we'll actually start distributing materials to everyone. The timing is because BioBricks Foundation is trying to get many institutions and academic labs and industry leaders to sign the Open MTA so that we can get better crosstalk between, the biohacking community and the academics and the industry, which I think would be really useful for people who want to get materials that are recently been researched, are getting researched, brand new cutting-edge, bleeding-edge technology. So the 10K Gene Project, which I'm specifically working on, we got 10,000 genes from Twist, and it's up to anyone in the biohacking community or the biology community to tell us what would be useful to synthesize. Even for your projects. If you think you have a cool idea, then you want to synthesize the Lux cassette, go for it. And we have a way on our subreddit, so you can order those through us. And the only stipulation that we have is that the genes that you synthesize must be open source. If you synthesize something through us, we will post the DNA sequence online. But what I think is better than, say, the iGEM registry is that anyone can receive those materials, not just iGEM teams and not just academics. Anyone who signs the Open MTA can receive any material that is under it. Anything that is synthesized through this belongs to the community and the world, not just the lab who makes it. So, what's our timeline? We want to get some test runs going. So, on September 1st, we're going to send out a twist order of 500 genes. October 1st, we're sending out another order of 500 genes. November 1st, 500 more genes. And December 1st, 500 more genes. And we might scale up after that. So what will those 500 genes be? What are your projects? How can we help you? What would be useful to open source and make available to the world that you are working on as biohackers and in community labs? That's what we want to synthesize. We need your help. So visit our Reddit page and submit genes that you think would be good to synthesize. Helpful to the community, helpful to you. They will belong to the world in the spirit of open source. So, this is still a learning process for us. We're still trying to figure out the best way to synthesize genes, to get them out to people, to help people get involved with the open source community. So interact with us. Help us make a more efficient process, because right now we're just using Google Survey or emails to me. And more efficient, more open. Any suggestions would be greatly appreciated. And additionally, we are currently synthesizing in 1.8 kilobase pair linear fragments from Twist. Is there a better way? Should we distribute in plasmids? What should be included in those plasmids if so? What features should we have in each block? Should we have PCR primers on each end? What should we have? And what tools are best to create that would help the biohacking community? Taq polymerase, open source mammalian plasmids, open source plant plasmids, you name it, we can make it. And if you can characterize it, that would be even better to be able to share with more people. What useful tools? Just for a small brainstorming session I had, PFU, T4 ligase, restriction enzymes, Gibson assembly enzymes, DNA ladder, small plasmids, plasmids you can't get, plasmids that are under AdGene but you can't redistribute. You can synthesize all of that for the community and for it to belong to the world. That's the goal of this project. So, if you want to make tools, we are giving you the synthesized DNA to be able to do that. And the only thing that you have to pay is making that open to everyone. Limitations. We have to talk about limitations of DNA synthesis. First is 1.8 kilobase pair linear fragment from Twist. Twist is not very good at synthesizing very complex DNA, so large GC or low GC or large repeats can't be synthesized, and use IDTG blocks. And we'll email you if we can't synthesize your gene, so maybe you can change it a bit. And also, don't just submit like the E. coli genome or the human genome. So then that is the main part of the BioNet project. We want you to be able to make tools for the community that the community will be able to use that will be useful to you and the community. And so then I have a few ideas that are going further than that to be able to help more people. The first is called Catalog. Cell-associated transferable assembled library of genes. I know some people don't like storing plasmids in B sublis, don't like that idea, but it might be a good idea. Imagine we can have the entire BioBricks registry in a single spore, a single Bacillus natto that you can put in fermented soybeans, or a single yeast cell that you could use for making beer or bread, and have the entire BioBricks registry in that single spore. So by sending someone that single cell or a small dab on a piece of paper, you'll be able to send them the entire BioBricks registry, all iGEM parts ever created. Perhaps all parts that are ever created through this program in a single cell. Request for comments. Do you think that's a good idea? Do you think it's a bad idea? Another idea I had is actually just storing plasmids in spores. So make an E. coli, sublis, or yeast shuttle plasmid that you put your open source genes over the GFP, however you want, and then you get those genes, and they can be put into spores. And those spores can be distributed to everyone for nearly free. Spores are so cheap to make that we could give out thousands to every person so that they can just give it to their friends, give it to whoever. And you can't stop that distribution network because once everyone has material, well, you can't stop people from getting it. And we have requests for comments on both these. Email me, do you think it's a good idea? Do you think it's a bad idea? Do you think that there should be other projects that the BioNet is working on with these 10,000 genes we have? It's all open. And then discussion questions. Any questions? Any points?